Let p of x be a polynomial in the real variable x of degree 5. Then the limit as n approaches infinity of p of n divided by 2 to the power n is. Which of the following is correct? First pause video and try from yourself. Let p of n be a polynomial of degree 5. Consider the limit of p of n divided by 2 power n. This is an infinity by infinity form. Applying L'Hospital rule for the first time. Applying L'Hospital rule again. After applying L'Hospital rule 5 times, we obtain this limit. As n tends to infinity, the value of this expression is 0. Therefore, option C is correct. In general, any polynomial grows slower than an exponential function. Find the largest term in the sequence xn equals 1000 power n divided by n factorial, where n is a natural number. Choose the correct option. We are given the sequence xn equal to 1000 power n divided by n factorial. We use the known inequality that a power x is less than x power y for large values of x. This sequence is first increasing, and after some point it starts decreasing. For large n, the next term is less than or equal to the previous term. Substituting the formula of the sequence. After simplification, we obtain this inequality. This gives n greater than or equal to 999. Therefore, the sequence attains its maximum value at x 999. Question. Let xn equal 2 to the power 2n times the quantity 1 minus cosine of 1 over 2 to the power n for all natural numbers n. The sequence xn. Option A does not converge. Option B converges to 0. Option C converges to 1/2. Option D converges to 1/4. Think carefully and choose the correct option. Given the sequence xn equals 2 to the power 2n times 1 minus cosine of 1 over 2 to the power n. We use the Taylor expansion of cosine x for small values of x. Since 1 over 2 power n tends to 0, we can apply this expansion. First we write 1 minus cosine x using Taylor expansion. Now substitute x equals 1 over 2 to the power n. This is the original sequence expression. Substitute the Taylor expansion and multiply by 2 to the power 2n. As n tends to infinity, the remaining small term goes to 0. Hence, the limit of the sequence is 1/2. Hence, the sequence converges to 1/2. Question. Let xn be a sequence of real numbers such that the limit as n tends to infinity of xn plus 1 minus xn is equal to c, where c is a positive real number. Then the sequence xn divided by n is. Option A. The sequence is not bounded. Option B. The sequence is bounded but not convergent. Option C. The sequence converges to c. Option D. The sequence converges to 0. Think carefully and choose the correct option. We are given that xn plus 1 minus xn tends to a positive number c. This means the sequence grows steadily. We can write xn as the first term plus all the differences up to n. Think of it as climbing steps one by one. Divide both sides by n. This is the average step size so far. Take the limit as n goes to infinity. The first part is the first term divided by n. The second part is the average of all the differences. Here comes Cesaro's idea. The first term goes to 0 and the average of differences tends to c. Hence, the limit is c. Therefore, the sequence xn divided by n converges to c. Correct option is c. Question. If a sub n is a convergent sequence, then Option A, infinity. Option B, 1. Option C, e. Option D, 0.